Now, a little guidance on comparing the predictions of the model with observations. Hopefully you have some idea what I meant by that and you were able to follow my instructions. But there's a lot of room for interpretation, especially when you're unfamiliar with this sort of thing. So I'm going to come down here and do just a little bit. Let's say that you had lengths of 12, 20, 30, and 50, and that would be apparently in centimeters. And you observed, you counted. For a 12 centimeter pendulum, you counted 106 cycles in a minute. 20 centimeters, you counted 72. 30 centimeters, you counted 53. For 50 centimeters, you counted 37. Now, when you did your graph, let's say you had come up with L to the negative 0.64. In other words, you came up with the y factor that gave you a power of negative 0.64 and 480 for your value of a in the y equals ax to the p form of a power function. Okay, so, those are the numbers that we got when we worked out the hypothetical model. Okay, so, what are your predicted values? Okay, by predicted, these are the predictions of the model. Well, to get the predicted values, you plug your length into the model and see what your predicted frequencies are. So we plug 12 into this model, and I think we get something like 109. Okay, and we plug 20 into the model, and I think that came out like 73. We plug 30 into the model. I think that was 54. And we plug 50 into the model, and I think that came out about 40. Might have been 39. Okay? And of course you can plug into this model and verify these predictions. It's very easy. Just plug in your numbers, use your calculator. Okay, so now what we want to do is evaluate how well the predictions match the observations. And in this case, they would match pretty well. We're off by 3 here. We're off by 1 here. We're off by 1 here. We're off by 3 here. We don't worry, at least when we're finding the deviation, we don't worry. Well, a deviation is an absolute value. It doesn't matter whether the prediction is greater than the observation or the observation greater than the prediction. Sometimes that does matter, and then we calculate what we call the residual, which is the same thing, but we use positive or negative depending on which is greater, the prediction or the observation. So, our deviation here is 3. Our deviation here is 1. Our deviation here is 1. Our deviation here is 3. The total of those deviations is 5. There were 4 of them. So we could say maybe that the average of our deviations was 1.2, which isn't too bad. We could also express each deviation as a percent of the prediction. So this is about 3% of this. This is a little over 1% of this. This is about 2% of this. And this is about 7% of this. So those are just ways that we could use this kind of information and ways that we could begin to evaluate the validity and the precision of our model. So I would say in this case, this would indicate a pretty good model. Now these aren't actual observations of a pendulum. These are just hypothetical observations. I want you to use your observations with your function and make your predictions, find your deviations, and see how well your model works.